Welcome back to the May 6th, the second day of May. And this is actually a question that was on the test. And so if you're a future student of our professor and somehow, some way you're seeing this video, then I got you. And so first, the system that is set up is there is a block and there is like a circular bowl, I guess I should say, that this mass goes around. And so what we first know is that the radius in which it goes around in is 1 meter. The velocity it goes around in is 3.84 meters per second. And obviously gravity is 9.81 meters per second. And so what we're supposed to solve is what is the angle in which the block is rotating about. And so let's first start off with the free body diagram, where we have our mg and we have our normal force. And the way to go about solving this question is splitting up this normal force, where we have nx, or f of nx and f of ny. And f of nx, if this is the angle, right? If that's the theta, is going to equal f of n sine theta, whereas f of ny is going to equal fn cosine theta. And so we have these values. And so let's just write them out here. Fn sine theta and fn cosine theta. And now we have our thetas. There's some way, somehow, we are able to derive these thetas to arrive at some sort of destination. What we're supposed to do is we're supposed to write it to where we isolate theta in terms of the variables that we have and then numerically solve it out. And so what we can do is, okay, using this free body diagram, what does fn sine theta equal? Okay, it's moving around in a circular object. That means there is going to be a centripetal force. What do we know centripetal force is? Well, we know centripetal force as Fc equals mv squared over r. Okay, so f of x, or f of n of x is that, right? Exactly that, what it is. And fn cosine theta, looking at it, well, that just goes against mg, so that should just equal mg, building upon concepts that we learned earlier in the semester. And so now that we have that, you look at it one more time, but you're like, oh wait, this r, we don't have anything for this r, because this r right here, that's not big R. This r, this small r you can call it, is going to equal r sine theta. And so instead of it just being small r, we wanted to get into variables that we have values for, so it should be sine theta, right? Because using Pythagorean's theorem, or just, or not Pythagorean's theorem, just knowing of trigonometry, you know that hypotenuse, let's call this adjacent and, or adjacent, opposite and adjacent, and just a little trig lesson, I suppose, hypotenuse. So good. Oh, opposite over hypotenuse. Sorry. Opposite over hypotenuse. So the hypotenuse equals, the opposite equals sine theta h, which in our case is going to equal r sine theta. And so that's how we get our value, just to clear up any confusion that we have. So now that we have these, mv squared over r sine theta time, or in mg, we're like, how do we somehow manage to get it so we can isolate theta? Well, if you look at it here, you know the fn should equal to each other. It's just that now there's a fn cosine theta, fn sine theta, but fn, that value itself, the normal force, should be equal no matter what, because these are the x of that normal force, the y of that normal force, but the normal force stays the same, or is the same for both. And so let's set them equal to each other, right? Where we set it up to where it's fn, the first equation, is going to equal mv squared r sine theta, And since you bring it down here, squared mg over cosine theta, right? And so now let's set these equal to each other. mv squared over r sine squared theta equals mg cosine theta. And so we have this, and so let's multiply, and so you should get those equal to each other. So you should get cosine theta mv squared equals mg r sine 2 theta. Now we're kind of going back to algebra, what we know with trigonometry, but first let's cancel out our m's, and we should get, and since this cosine theta and sine theta, I want them to be both on the same side, so let's get v squared over, and then bring the gr over here, sine part 2 cosine theta. It's kind of just backtrack a little bit just so I don't lose some of you guys. We have our free body diagram, normal force, components of the normal force. So we set up our axis to be x here, y here. The x component of normal force, the y component of the normal force is Fn cosine theta, Fn sine theta. That's just trigonometry. We know that since the mg is opposing the normal force in the x direction, that's what it equals. And then since the force, right, in this x direction and it's moving in a circular direction, is going to equal the centripetal force, right, which is mv squared over r. R in this case, if you look over here, this r is the sine theta times the big R, so that's why it's mv squared over big R sine theta. And we have these values. You set the two normal forces equal to each other, you do a little bit of rearranging, and you arrive to what we have right now. Now this is a trig identity that you need to remember, something that most people might not have on the spot, but something that you definitely learn in your math classes, or haven't learned in your math classes, equals 1. We could plug that in right here, right? Because sine part of 2 theta equals 1 minus cosine theta. So v squared over gr equals 1 minus. So now we have that. And since on this side they're all given values, let's solve that out, where we have 3.84 squared for 9.81, and we know that the radius is 1, equals our thing. And I might just erase that, so keep in mind this trig identity. This is something that you just know, you just need to know. And it helps us solve our question. And so now that we have that, if you plug that into your calculator, you should get 1.5 equals 1 minus cosine theta. Right, and you have this right here. Now if you try to solve it where you go 1.4 equals 1 divided by cosine theta minus 1, and you try solving it out, it doesn't work. Or it is possible, but it becomes very, you could see for yourselves here, where let's do that, where we have 1 over cosine theta equals, or not equals, minus cosine theta. You look at it and you're like, wait a minute, okay, what do I do from here? You get lost, you get stuck. So instead of taking an approach this way, how about we set it up so that cosine theta is just one variable? Forget about the cosine and the theta, just think of cosine theta as 1. So set up cosine theta to where equal is just one variable, x, and now it looks like something that very manageable, very easy to do. Something that you could arguably do in 6th grade. So you bring this out here, 1, boom. Now you just need to do the quadratic formula, right? Equals 0. And so now that we have that, yeah, just the quadratic formula is equals negative 1.5 Sorry, let me relook at my notes. Sorry, this is not a negative yet. That makes that a negative. It should be -1, not +1. Even a 6th grader should be able to do it, and yet I'm making mistakes. Sorry about that, but we know it's negative b plus or minus the square root b squared minus 4ac all over 2a. And so with that formula, you get negative 1.5 plus or minus 1.5 squared minus 4a, which is 1, c negative 1, all over 2a, but a is just 1. So you get that value. You actually end up getting two values because the plus or minus 0.5 and -2. But we know that the values for theta cannot be going outside -1 or 1. So you just cancel out this value right here. And so you have 0.4 or 0.5 as your cosine theta, not your theta, your cosine theta. And so your cosine theta is going to equal 0.5. And then once you have that value, you just do very simple trig or just math, I suppose. Right, and you do that, your angle that you get is 60 degrees. So a lot of moving parts in this thing, a lot of things to consider. You know, you have your free body diagrams, you're setting things equal to each other, a lot of very trig identity heavy with this right here. Just kind of a little bit of manipulation of math, not too much, not really, but making your cosine theta equal x, and stuff like that, where you kind of have to really think outside the box. It's not really one of those questions where it's like, oh, you have your numbers, you have a certain like formula, boom, plug in, get your answer. It is like that, but now you got to really rearrange your formulas, rearrange certain identities to get your answer. And so our answer that we get is 60 degrees. And so that's what I have for you guys. This is actually a test question. So like I mentioned, if you're watching this somehow next semester or any semester after that, boom, this is the answer for you guys. You actually end up working on it in class as well, but just a more in-depth, detailed description of how to actually solve this question. And for those that are in my class that didn't actually understand how to do it, this is my explanation. And so if there's anything that I missed out on, or if there was anything unclear, feel free to comment or let me know. That's all I have for you guys. Thank you, and I'll see you guys next week.